Another big topic that we talk about this year is waves. Waves is a very big topic in physics and will bring us through probably the next month of learning. So, when we talk about waves, waves itself, the topic is broken into multiple pieces. We're going to start with talking about waves, the very basic of waves, which are called pulses. So, a pulse is a single vibratory disturbance that transfers energy but not mass. That's important. So, when you think about, like, if you're laying outside on the beach, which hopefully you will be able to do this year, if you're laying outside and you are tanning, think about what happens. You're laying there and you're feeling the waves from the sun, you're feeling the heat from the sun. But when you get up, say if you're on the beach for like 5 hours, you get up, you may be tan, but did you automatically gain like 20 pounds? No, because you're not going to have a transfer of mass. So the only thing that transfers is energy, so the heat energy that you feel. But mass itself is never ever transferred. So when you're talking about waves, only energy can be transferred. Also, when we talk about waves, we talk about something called amplitude. Amplitude is the height of a wave pulse. So one little hump on a wave from your equilibrium position. Amplitude is directly proportional to energy. So as soon as you hear amplitude, automatically you should think about energy. And lastly is a medium. And a medium is a continuum of particles of a single type. So a medium is just the kind of material or the substance that your wave is traveling through. So we could talk about a medium being a wall, a medium being a particular item that we want to transfer energy through or your wave through. A medium can be space, it can be air, it could be water, it could be aluminum foil for all that, for all we know. But a medium is a particular type of material. The medium stores, then releases the energy as pulses when they travel through it. So the medium, so as you are in, say, water, if you're in a pool or the ocean and you're underneath the surface of the water, if you start to talk under the water, people above the water may be able to hear some kind of like muffled sound, but they won't actually be able to hear you and what you're actually speaking, right? So the medium will store that energy and it will allow the waves to travel through, but it may come out a little bit different on the other side. So when we talk about pulses, we can talk about different things that are able to happen and the reasons that you're able to hear sounds or see light or experience particular types of waves like radio, microwaves, X-rays, if you ever had one before. So the first thing that we talk about is reflection. So this picture here is showing you wave reflection. So we'll wait till it starts back up. So now your wave is traveling to the right. When it hits the right, it's reflected and it's reflected back. And if you notice in this particular picture here, this is what we call a fixed point. So when something is fixed, that means that there's no way for it to move. So the end of this wave or the end of the in the x-axis is fixed at that equilibrium position there at zero. There's no way that it's going to be able to move or travel. So when you have a fixed point, your wave pulse, this one little hump, is reflected back, but it's reflected back in the opposite direction, meaning if it's going in the negative, it will be reflected in the positive. If it's in the positive, it will be reflected in the negative. The other type that we have is that of a floating point. And a floating point means that it's not fixed, meaning that it has the ability to move as the wave is traveling. So when you have a floating point, if you notice, you do have reflection, except now you're reflected back in the same direction, meaning that you're reflected back. If you're traveling in the positive, you'll come back in the positive. If you're reflected in the negative, you'll come back in the negative. You can think about this like if you have, say, a jump rope. I know when I was in school, like on the playground during lunch, girls would play, what did they call that? Double Dutch. I think that's what they called it. And you would have like the two people on either end, and then you would, together be rotating the jump rope and people would jump in. So in that case, you have a fixed point. But if you don't have anybody on the other end, well, that's a floating point where nothing is holding it in place. When we talk about changing mediums, the mediums that we talk about will affect your wave in different ways. So, when we talk about changing mediums, this wave, when your wave enters into a medium, part of it is transmitted, meaning that part of it goes through the wave, through the medium, and part of it is reflected back. So, when you're speaking, as you're speaking in your room, you're able to have this wave, your sound wave, be reflected back, so as a reflection, so that you're able to hear yourself, and part of your sound is transmitted into the wall. So part of that energy, you're losing some of that energy as it's transmitted. So when we talk about this, we're talking about a couple of different situations. So first, when we go from a low density to a high density medium, for instance, air into water. So think about density, how tightly packed those molecules will have to be. So as you're going from air, which in this case is the skinny line, and water, which is the thicker line, you notice when the wave hits into the water, part of that wave is reflected back, smaller. Part of that wave is transmitted into the water or into the thicker medium. When you go backwards, as you go from, say, water into air, again, part of that wave is going to be reflected back. And because you have so much more room that you can spread out in a less dense material, some of that, or you're going to have a greater amplitude or a greater height of your wave or more energy that's coming out because you have more room to be able to expand. We could also talk about interference. And when we talk about interference, to interfere means to come into contact, right? So pulses that encounter one another interfere with each other. We have two types of interference that we talk about. The first is constructive. The second is destructive. When these pulses, when these waves come together, this is called the principle of superposition, where you superimpose waves on top of each other. So we start with constructive. Constructive, if you want to construct, you're creating, you're making things bigger. Think about if you're constructing like a building, you're creating a building. So when you have constructive interference, if you notice when these two waves come together, you have a larger amplitude that results. So when you have constructive interference, that means that your wave pulses are traveling in the same direction, meaning that they are both in the positive or both in the negative. Energy of your two wave pulses, so the amplitude of your wave pulses, is added together because you want to construct to create a greater amplitude. So if you look at this situation here, you have these two boxes. Now, one thing to just keep in mind, wave pulses can be represented as any shape. Waves themselves are spherical, meaning that they're circular in shape. However, when we draw them or we create them, we can draw them with really any shape. We just have to be consistent. So here they're drawn with two little boxes. Okay, both of these boxes look to have about the same amplitude. In a question, you won't have any guessing. You'll have like actual numbers to be working with. But both of these wave pulses are coming together towards each other. When they come together, they superimpose on top of each other. So they double in size, which means that they just become one. So that's like you and your friend running towards each other, especially after this whole quarantine situation, right? You're like desperate to see people. I know I am. And you're running towards each other and you embrace, you hug. And now all of a sudden, rather than be two separate people, you're one unit. That's what this is. And the moment that you're like, okay, I've had enough of you, you then continue and travel on your own way. And that's exactly what happens here. So they interfere, but then they just continue to move in their own directions, like this picture shows you. The other type that we have is destructive interference. And destructive interference, again, you superimpose, so you're putting your waves right on top of each other, except now you have one in the positive, one in the negative. To destruct means to destroy, right? So if you are talking about destructive, then you're basically subtracting your amplitudes. So if you look at this picture here, when they get to zero, they combine, but because they have the same amplitude, if you subtract them, then essentially they their amplitude together would be 0. So that's why they like disappear for a second. But then they just continue back in their same directions. So like if you look at the one on the top, after they superimpose, it continues back moving to the left. The one on the bottom continues back moving to the right. So again, destructive interference is when you have your pulses in opposite directions, so positive and negative. The energy of your pulses partially or completely cancels out. So this particular diagram that you have here, well, both of the amplitudes are the same, so that's why you have an amplitude of 0 when they intersect. It won't always be the same. Sometimes, like, they could be all different. So that's why it says partially or completely cancels out. Regardless, you will always have a lower amplitude if you're talking about destructive interference. So for this one, you have a wave coming, or a pulse coming on the top, a pulse coming on the bottom. When they combine together, when they are superimposed on each other, because you have a positive on the top, a negative on the bottom, and because they are about the same amplitude, when they combine, essentially their amplitude is going to be 0. As they continue after this, they just continue back in their normal directions. So the top one still continues to the right. The one in the negative still continues to the left. And you're left with your wave pulses going back in the same direction.